welcome everyone to our March Clinical AI Interest Group meeting. Thanks so much for joining us. So just a couple of bits of intros from us, really. First up is that there's a couple of events coming up from the Clinical AI Interest Group over the next couple of months. So some dates that will be sent around in the upcoming emails. But just for your calendar, so 30th of April in the afternoon, we're going to be hosting a really exciting interest group. What's the word and what do we call it in the end?
AI Fringe event.
Yeah,
AI UK Fringe event.
We have a better name for it, don't we? It's the Super
Interest Showcase.
That's it. There we go. We'll get the branding right. Be great to see as many people as possible joining us for that. As well, there's another event I will very cheekily just flag to all of you that on the 27th of March at 1 p.m, I think, let me just confirm that time for you. Yep, me and some colleagues at the University of Birmingham are hosting an event also part of the Turing AI Fringe on participatory research practice in digital health and AI. So please do feel free to join us for that. I'll drop a registration link in the chat. Anything else I'm missing, Alicia or Emma, as far as updates go?
I have another one, Joe.
I'll go on then.
And this is another part of the AI UK Fringe. I think the Clinical AI group is propping it up, but it's got a focus on public health this time. So with the Faculty of Public Health, we're having a Fringe discussion next Friday. I'll pop the link in the chat about new horizons in public health and the use of AI in public health in the UK. As well too, so another one for you all.
Fantastic. So a whole series of events for anyone to join us on. I suppose we should mention as well that this is all part of the Turing's AI UK conference. So whilst we're talking about the fringe events here, which are the kind of like free to join events, normally an hour or two kind of online or hybrid stuff, there's actually part of a 2-day conference hosted by the Turing with scope well beyond healthcare AI. It's AI in general. We can drop some links again in the chat to that, but might be of interest to some people. I think registration's still open.
Still open for online. It's actually free if you register on the AI UK website, and I'll put that in the chat in a minute. It is actually free to register, and it's live streamed all of AI UK. So it's next Tuesday and Wednesday. I actually have another thing to advertise as well, which is on the 30th of April in the morning. We are actually having the second part of our summer school, which is obviously not in the summer, it's more of a spring school. And this is more of a practical workshop. We do have a couple of, because we had people that we recruited through applications for last year's summer school. So we invited those people, but we actually have about another 10 places left. So if anyone here is particularly interested, they can send me an email. I'll drop my email in the chat, but I will send out a message to the whole group because I do want to fill up all of the spaces so that we have a full cohort for that particular day as well. So if you do come for that, you can then stay for the AI UK Fringe event as well that we're putting on at the Turing and be there in person.
Fantastic. Thanks so much, Emma. Alicia, over to you.
Thanks, Joe. I'm actually on the wrong computer and I can't find the introductions list. Are we doing introductions now?
Yeah, we are. Do you want me to take this bit?
Yes, please.
Yeah, no,
sorry, Joe.
It's okay. So I think we have a couple of people who have very kindly agreed to introduce themselves and talk a little bit about what they're up to. So first up, if they're on the call, can I go to Emily Clark? Emily, if you're there, over to you. Feel free to unmute and tell us a bit about yourself.
Hello? Hi, can everybody hear me? Great. Okay, I'll get cracking. Thank you so much for this opportunity to introduce myself and tell you about the work that we're doing. Am I allowed to share my screen just briefly for a couple of slides?
Yeah, go for it.
Yes, please.
Great. So I'm Emily Clark. I'm based in Leeds. I'm a histopathology registrar, and I'm currently out of the program, having just completed my PhD and looking to imminently return to clinical practice as a clinical lecturer. Just to say that for those that don't know, we are home to the National Pathology Imaging Cooperative, founded by Professor Darren Trainer. MPIC is a project spanning both clinical systems and an academic platform for AI in pathology, with an initial network of 30 hospitals now around the UK. So just to give you a little bit of background to what we're doing in Leeds, and also as a bit of a bid, as an aspiring dermatopathologist, my field of interest is skin pathology and particularly melanomas. My PhD was concerned with the development of CNNs to help identify the first objective diagnostic biomarkers in melanoma based on the H&E morphology. And you can see one of the segmentation results of one of the CNNs here on the right with the areas of tumour detected in red. And I'd like to take this opportunity to ask if anybody would like to collaborate by sharing anonymised image data. So in the field of pathology, of course, that's whole slide images of melanomas or melanoma lymph node specimens, then please do get in touch to ensure the validity of the biomarkers. The more data, the better, and I'm sure you'll all agree. And also to say that if anybody has any expertise in computer vision, MPIC are recruiting personnel quite regularly in this area. So please do get in touch and keep an eye out for job postings on social media or through our trust website. Thank you ever so much.
Thank you so much, Emily. That's really fantastic. Really clear presentation and a call to action from anyone there. Anyone got any questions for Emily before we move on to our next quick intro? If not, then feel free to drop them in the chat or to reach out to Emily directly. Emily, do you want to just pop your email address maybe in the chat in case anyone wants to reach out?
Yeah, thanks ever so much.
No problem, thank you. And then we're graced with another 4-minute or 3-minute intro. So Aditya Agarwal, can I hand over to yourself, please?
Of course, thank you so much, Joe, for that. Hi everybody, my name is Aditya Agarwal. I'm a pharmacist by background, currently working as a manager in a hospital. Sorry, I lost my notes here. I think so. What my call to ask is that I'm looking to set up the Turing, a new super interest group within the Turing Clinical AI group for pharmacy AI, where I see 3 distinct parts to it. One of which is within life sciences, another part within clinical pharmacy, and another part in pharmacy operations. This is what I see as the overall space of where AI can have an impact in pharmacy. And the call to action for this group is, if anyone is interested in that, perhaps for people who have an interest in the AI space, people who have an interest in operational or clinical operational aspects of AI, this perhaps could be a space where we can do some interesting things. And so if you're interested, please do reach out, and and we can perhaps collaborate and get this group off the ground. Just to also add, is where this comes from is I did a thesis at Imperial, part of my master's in health policy, which looked at the AI application of in pharmacy, and there were a number of different aspects and of that, which to increase the uptake and even the development of AI within pharmacy. And one element of that was in order to develop a multidisciplinary team in order to try and take this off the ground. And I think the Turing Institute is one such place where we could achieve great things. Thank you.
Fantastic, thanks so much, Aditya. Again, if you could just pop your contact details in the chat in case anyone does want to reach out. Any questions for Aditya, also feel free to pop them in the chat or reach out directly that ask them for kind of co-lead for that theme. So if that's something that might interest you, or someone that might be interested, then feel free to reach out to Aditya. Thanks so much to our introductory speakers. I'm really grateful for your sticking your head above the parapet. If you're interested in giving a intro in any of our future meetings, then feel free to let us know, and we'd be delighted to give you that platform. So over to you, Alicia, for the next part.
Thanks, Joe. Now I'd like to introduce Venet Osmani, Associate Professor of Data Science and Health at University of Sheffield. Venet is going to talk to us today about generative AI for synthetic clinical data and some of the challenges and opportunities. Really delighted to have Venet with us, reflecting on the challenges in evaluating synthetic clinical data as well, and that really important question about the fidelity and the privacy and equity as well too. So Venet, I know we've got your slides and things and you're all linked up, so over to you.
Thank you very much for the introduction, and thank you also for the invite. I'm happy to be here. So I'll just start by sharing the screen first, and then, all right. Can you see it?
Yeah, it looks perfect.
Yeah, great.
Okay. Because I cannot see you anymore, so I'm just going to go on. So hello, everyone. So just a few things about myself. So I'm an associate professor here at University of Sheffield. I also co-direct Health Informatics Research Group, which we are now about a little bit over 40 members, really. And then I also co-direct a Wellcome-funded doctoral training center on public health. In addition to this, I also have a few roles within the flagship institutes of the University of Sheffield and a few other institutes as well. Sorry, I can hear an echo from somewhere, so maybe if you can mute your microphones. So I'm just going to start off with kind of a challenge. So, what are we talking about? Because I'm sure, many people have heard about generative AI, but that, tends to be concentrated either towards text or towards images. And in here, we are doing something a bit different. So the question that we are trying to answer is that can we generate high fidelity synthetic patient data complete with their clinical history? And how is this different from, ChatGPT and all other systems? So for those that don't know what basically ChatGPT does, but not only other generative AI models that are quite popular right now. So what they do is they take documents, in this case, text from all over the internet, build kind of a predictive model, as you can see in here. And then, as you type a query, they predict the next word and generate some useful text most of the time. Now, what we are doing is something different. So instead of text, we are actually taking electronic health records of patients, of many patients. Then using those, we are building a generative model, which we call CA and CA-GAN. And CA stands for conditional. GAN is a method that's used for generative AI called generative adversarial networks, in this case referring to neural nets. And then from the kind of the set of electronic health records that we have, what we are doing is we are generating synthetic electronic health records. And this is not, just for a single patient or a single variable. We are actually generating whole synthetic patients together with demographic information, clinical variables such as blood tests and things like that, and whatever is actually contained on electronic health records. So at this point, I just wanted, to kind of, clarify the concept. I guess if the concept is clear, the next question would be, why is this important? And there are several areas where synthetic data can actually play a significant role. One is improving representation. So we know that certain subpopulations, certain groups are underrepresented in health data. For example, groups with certain ethnic backgrounds, perhaps gender or other characteristics. So the issue is that if we were to actually use AI algorithms on those data, these algorithms would be quite unfair. And one of the reasons is that, when the learning happens, they learn from majority of the examples, meaning that they would not perform well on the minority class in this case, class as in classification in terms of machine learning. So what we want to do is we want to make sure that, we improve the representation of underrepresented groups. And at the same time, we want to use this work to mitigate algorithmic bias, which I mentioned previously. Of course, then this would lead to improving generalizability of the models, because when we establish these kind of predictive models, we want to make sure that they work well across different patient subpopulations, considering all sorts of demographic characteristics, but also clinical characteristics as well. And another area that I'm particularly excited about is the potential of synthetic data to actually improve access to clinical data. And the reason that I'm saying this is that we know that gaining access to clinical data is very difficult for all sorts of reasons, from legal, privacy, confidentiality, but also commercial. So synthetic data might be one way to actually address this problem, such that a kind of a surrogate of the real data is created, and then that can be used in actually advancing research. And this is something that we've started recently working on. Okay, so having said this, I want just to show you some of the work that we've done already and some of the associated results. So as a proof of concept, we had access to clinical records about 7,500 patients. A bit more than half were patients that were already diagnosed with sepsis, and another 3,000 with hypotension. The actual conditions don't really matter too much for this work. What matters here is that about 11 to 12% of those patients were patients of Black ethnicity, as self-reported in electronic health records. So, and then we took 48 hours of their clinical history, so from admission up to up to the second day. So one objective of this work was to see whether we can generate synthetic data of Black patients only, such that we improve the representation with respect to what we have here, 11 and 12%. So in order to achieve this kind of work, we've devised an architecture. So you can see on the left there. So our architecture is based on, as I mentioned at the beginning, on generative adversarial networks. For those of you that are not familiar with this kind of architecture, so basically what we have is we have two neural networks that are competing with each other. So one is a generator that initially just generates random samples. And another one is a discriminator, which tries to discriminate between the real patient data, so the real samples that we have, and synthetic samples. So as generator is generating, more and more data, the discriminator is actually feeding back to the generator how far it is from kind of incorrect values, if you want. So at some point, the generator becomes, quite good, such that discriminator cannot discriminate between real and synthetic data. So, and then we use the generator to actually generate the data that we want. One important aspect with this architecture is that it's a conditional architecture, meaning that once we have the model, we can condition the neural networks to generate any type of patient characteristics that we want. So in this case, we've generated, patients of Black ethnicity, but we can very easily generate, patients with diabetes, type 2 diabetes, or patients with other characteristics based on the needs. So for this, on the right, what you can see is several of the clinical variables that we've used for this work. And once we had the architecture, we started to actually evaluate, how good the data is. And this is, where the challenges begin. I'm not going to show all the results because, you know, there are many, but if you are interested, I will put up a link to 2 papers that one is under review and another one that has been published, and that contains, you know, a complete set of results. So today, what I want to focus is on some of the challenges of evaluation of synthetic data. So the biggest issue is that, well, the biggest question is which metrics to use. Of course, you know, both from the clinical part, but also from the machine learning part, you know, AUC is a very popular measure. But AUC on its own, while can be used for one type of evaluation of synthetic data, that's definitely not sufficient because it doesn't provide the whole story. Of course, one way to actually evaluate the quality of synthetic data is, you know, to look at manually, basically, you know, if you have a clinician and say how plausible it is that a specific patient is actually a real patient. But if you're generating data at large scale, of course, this is not scalable. And right now, there is no really consensus on the literature to say that, you know, one method or another should be used. But looking at the literature, kind of 2 broad approaches have emerged. So whenever, you know, researchers talk about evaluation of synthetic data, majority of the approaches either focus on qualitative evaluation, and this usually means some sort of visualization, or it's a quantitative evaluation. And typically, this would mean understanding the distance between distribution of variables. And I'm going to show examples of both what we've done in this work. So initially, I'll start with kind of a qualitative evaluation. So as I mentioned, this is through a visualization. So what we have here on the first part, we have basically 3 methods. SMOD is the most simple, is the simplest method. It's basically a method where, so what the SMOD algorithm does, it looks at the kind of the neighboring points, takes an average. So if you think, you know, I don't know, a set of blood pressures for all the patients, takes an average point and generates a new point as an average of those. So it's quite simple method, but it's very popular and it's quite a lot in use. WGAN-GP is state of the art. So this is what we are comparing our architecture against. And then CA-GAN is our own method. And what we have done here is we have used this method called principal component analysis to actually provide a 2-dimensional representation of all the variables that we had over all the patients. So each red dot represents kind of a point in real data, and the blue dots represent synthetic data. So what we want here is we want to see how much coverage synthetic data, how much synthetic data cover real data. And what we can see in here is that, you know, SMOD is not really doing very well because it's only generating a very small portion of synthetic data. So all these real data are remaining on their own. WGAN-GP, so state-of-the-art method, does a bit better in terms of coverage. You can see here. But the method that we've developed works best. So we have the kind of the widest coverage of synthetic data with respect to the real data. So this is kind of at the level of the data set themselves. So we had, you know, these 2 patients with hypotensive patients and those with sepsis. But of course, this is not sufficient. What we want to do is we also want to understand, for example, you know, how does the distribution of individual variables looks like, of individual clinical variables that I showed you before. So we've done some analysis in there. This is just one example. I'll show you all the variables later on. So in terms of arterial pressure, SMOD is doing pretty well. And, this is to be expected because for such a simple algorithm, it's going to capture quite well the distribution of individual variables. State-of-the-art method is not doing so well. And we are somewhere in between. We are missing the mean a bit, but we are capturing pretty well, I think, the distribution of mean arterial pressure. So this is a positive example. Where it doesn't work as well is in cases where we have distributions of variables with a long tail. So of course, creatinine is one of those variables. You can see that the simple method SMOTE works relatively well. State-of-the-art method misses the mean, by quite a wide margin. And while we are, capturing well, while we are capturing well the mean, there is still, some improvement also with our approach. So, but we know now that capturing capturing distribution of variables with a long tail distribution is a significant challenge. And in here you can see how we are doing with all the variables. So for some we are doing quite well, for some not so well. And then so these are continuous variables. For categorical variables in general, it's not an issue for any of the methods. So this is as far as qualitative evaluation. Now, what I want to do is also to show an aspect in terms of quantitative evaluation. So also in here, I'm not going to show all the results. I'm going to show only two examples. One, we want to see whether correlation between variables in the real data set are maintained also in synthetic data set. So apologies that, this is very, very small, but what we have here is all the variables, how they are correlated between each other on the real data set and on the synthetic data set. Ideally, what we want is for this graph to be a mirror of this graph, because that says that, correlation between the variables are maintained. And also in here, we are not doing too bad in terms of maintaining the correlations. And another aspect of quantitative evaluation is this concept of distance between distribution of individual variables. And this is what we have here. I won't go through the whole table, but what we have is basically we are using this KL divergence and MMD, which are two measures that tell us how distant the distribution of real variables with respect to synthetic variables. So what we want, of course, here is the smallest distance. So what we are saying is that, the variables with the smaller distribution means that they are closest as close to the real data as possible. So we want these numbers to be as small as possible, but not zero. And then I'll tell you why later on. So in this case, the method that we are proposing is doing relatively well. Now, one large issue with evaluation of synthetic data is that we always have these kind of competing objectives. So in one sense, we want to generate synthetic data of high fidelity, because if we use that data in further research, we want to make sure that the results we'll get are as representative of the real data as possible. But at the same time, we don't want to have synthetic data that are very similar or identical to the real data, because then if this data was to be released publicly, we run into all sorts of issues of privacy and confidentiality and patient re-identification and these things. And this is, you know, it's a significant challenge. Of course, you know, this is going to depend on case by case basis. I don't think there's going to be a kind of one answer to say, okay, you know, we should do it this way or another way. I think it's going to depend on, you know, how much fidelity we want to have on synthetic data, at the same time considering privacy and confidentiality issues. So this is as far as the results, and I'm gonna just say a few things in conclusion. So from the result that I've shown, we can see that the architecture that we are proposing does generate data with very high distribution coverage. We investigated if this data is authentic, and it is, and they are not. What's important is that the synthetic data that has been generated is not a mere copy of real data. We've also looked at how well synthetic data can actually improve predictive models as well. And we found that adding synthetic data actually improve prediction performance. So, as I said at the beginning, there is enormous potential really to allow to actually democratize access to clinical data. And, you know, this is a huge obstacle currently, and it's actually hindering research. So synthetic data is perhaps one of the approaches that can be used to address this challenge. However, as I've shown you through a few examples, generation of synthetic data does remain an open challenge. So also, you know, one of the reasons that I wanted also to do this presentation is to you know, to put out there a call for people who would be interested in collaborating, because the potential is enormous of using synthetic data. However, at the same time, there are quite a significant set of challenges that I think through collaboration we can tackle together. So lastly, well, first, thank you for attention. I would just wanted to acknowledge funding that has been provided by the Healthy Lifespan Institute and the PSRC to further advance this work. So we are actually building on top of this work right now. And first paper has been submitted to Nature Communications, which is still under the second review, but it can be accessed through preprint. And the second paper is from a workshop at NeuroAIMS. So I will stop here and happy to take questions.
Many thanks, Venet. It's just fascinating. So yeah, any questions, do feel free to pop up your hand or pop them in the chat. There's an ask there from Batul about could they have the link to the preprint, please? And are you happy to share your slides with people as well too? Thanks.
Absolutely, yeah, no problem. I can share them after this, yeah.
Wonderful, thanks, Venet. Reza, you have a question.
Hi, thank you very much, Venet, for your presentation. I'm Reza, working as a data scientist at the University of Nottingham. I have two questions, both of them about your model. The first one, I was curious to know what was the loss function you have used for your generator and the discriminator in order to penalize your model during training?
So to be honest, I don't remember because we submitted that quite a while back, but we definitely specified this in the paper itself. But what we have done is we did modify the loss function because I don't remember from which to which, but this was one of the issues because in order to get results better than state of the art, first we had to modify the loss function. We added another by LSTM network and we added another attention layer, if I remember correctly. Apologies that I cannot answer, but it's definitely on the paper.
No worries. Yeah, it was very interesting for me to see that you have used BiLSTM in your generator and discriminator model. The next question is about the overfitting on the training data. As you know, the GANs are the GANs intend to learn the training data distribution continuously. I mean, they will learn this distribution anywhere in the space that the data is there. But from the images I found, if I'm not correct, just correct me. From your presentation, I saw that the synthetic data are generated more condensed around your training data. So what have you done in order to make sure that your model is not overfitted to the training data?
So there are several things. I mean, you're right. I think, training GANs, but also things like diffusion models and things like that, it's a challenge. And, overfitting is one challenge. Another challenge to be faced is mode collapse, where, it's only a part of the training data is taken and, the samples are generated only with a very small distribution. So in terms of avoiding overfitting, we've battled this issue quite a lot. So we played a lot around early stopping and adding dropout layers. Through some trial and error, but also looking at the literature, we did manage to, in large part, to avoid overfitting. So these two were, I think, the main factors that influenced it.
Yeah, thank you very much.
Thank you.
Thanks, Reza. Joe, you have a question?
Yeah, I'm happy to go after the question on the chat there, if that's easy.
Oh, sorry, I missed that one. From Anna. Great work. Do you have considerations or intentions for
imaging? Yeah.
Oh, yeah, for imaging data later.
Yeah.
Any thoughts on that, Venet?
Yeah, that's a great question. And the thing is that, in here, we are really capturing tabular data. And that's, of course, that's only a part of a patient's clinical history. There is imaging, there is waveforms, and also different types of imaging as well. So right now, one of the strands on this work is to also integrate imaging. But while, generating synthetic data is a big challenge, generating multimodal data is even bigger challenge. And of course, there is one challenge before that as to how do you integrate everything. So how do you integrate different modalities? I think that's still an open question. So right now, with some of my colleagues, we are working on this first part. So how do we actually build a model that integrates different modalities, including tabular data, imaging, all sorts of imaging, X-ray, PETs, things like that, and waveforms as well, like ECG, EEG, and all those. And then I think once we figured out an optimal way to do this, then the next step is going to be on actually generating multimodal data. But I think that's a bit still will take some time.
Actually, there's some learning from a Turing program that worked with UKHSA on integration of different types of data over time and space. I can send you some of those. It might spark some other ideas. Joe.
Yeah, thanks. Thanks for that really fantastic presentation. I've got a couple of questions, but I'll ask my first one, and then if anyone else pipes up with anything more interesting, I'll shut up. But maybe I'll ask my second one later on. So first question was, well, generating kind of high quality synthetic data is going to be really helpful into kind of mitigate some of those representation biases of people that are present in data sets. But I guess one of the fundamental limitations of synthetic generated data will be that if people are just structurally absent from data for whatever reason, then they can't be simulated because they're just not there in the first place. There's nothing for the generative models to learn from. So I guess the question is there any technical solution for that? Maybe going out into communities, purposefully sampling underrepresented minoritized communities, and then in some way amplifying those people back into data sets, or is that just going to be a problem for new biases and new issues? I wonder what your thoughts are on that.
Yeah, no, that's a great question, really. And underrepresentation is such a multifaceted problem that what I'm showing here is just one way to somewhat mitigate the issue, because you're right. I think what we are really missing here is to understand when there is a fact of underrepresentation, we don't have the data. So the challenge that we are addressing here is that if we were to apply AI algorithms on existing clinical data, we don't want to kind of perpetuate existing inequalities. Now, but your point is right, and I think it's probably not a technical challenge. I think it's more a kind of a socioeconomic challenge, really. And how to address that, I don't have, of course, an answer. And I assume, there is not one single answer. There are multiple answers. But, perhaps going into communities and seeing whether underrepresentation can be somewhat improved might be one way. But I think this plays into kind of wider socioeconomic factors as well. And I think, those need to be considered quite carefully. So, but yeah, you're absolutely right. It's quite a challenging problem.
Joe, before you go into your second question, Venet, can I ask one, kind of building on that a little bit, because I liked your earlier you mentioned that generating synthetic data with different kind of demographic groups or ethnic groups, and that being able to, I was wondering if synthetic data gives us the potential to kind of knock out some of those groups, to just sort of reverse it, if you like. So to understand, if you apply an AI tool, how well it will work if there's over or under representation of those different population groups. And is that something where actually synthetic data could potentially help as well, to help us to understand the performance?
Yeah, you're right, absolutely. And because the way that we designed the architecture to be conditional, we can generate first any type of data that we have, of course, in our model. And second thing is that we can also manipulate the ratios. So we manipulate ratios between, certain ethnic groups, within demographic subpopulations, things like that. And then, do all sorts of investigations to understand, for example, if there is an underrepresentation or overrepresentation, although I don't know how that could be, but still, at least as a thought experiment. So all these sorts of issues can actually be investigated using synthetic data, given the flexibility that this, but also other architectures have.
Lovely, thanks. Sorry, Joe, I jumped in. Go on ahead with your second question.
Thank you. So my second question may be a slightly easier one, but I wondered if you thought that there were any use cases that were particularly helpful where generative AI and synthetic data might be useful, and on the flip side, any use cases where you think synthetic data just fundamentally shouldn't be used.
Well, one use case that I've started working with is rare diseases. So we are looking, I'm working with, I'm starting to work with a pharmaceutical company, and they are interested in, augmenting their data set because they're developing a drug for the rare diseases. So I think, using these models, the synthetic data for rare diseases, I think would be an interesting use case. I guess, the kind of exciting work that I mentioned also in the past is this concept of democratizing access to clinical data. Of course, that's not a single use case, but I think, the potential there is enormous to really advance clinical research. Because I'm sure many of you are aware here that getting access to clinical data is still a very, very big challenge. Even though there are many initiatives, some also at University of Sheffield here, to provide access to this data, but the obstacles are enormous as well. So I guess these two would be probably a few examples of the use of synthetic data.
Lovely. Thanks, Venet. I wonder were there any other, I think we've covered most of the questions. I'm just trying to find Aditya, sorry, not Aditya, who asked? Anna. I'm just trying to find the right links, and then I'll put them in the chat, or we can share them another time. Any other questions for Venet?
I think there was one in chat, right? I don't know, is it Jianan, if you want to ask that question?
Oh, yes, I missed that one. Sorry, Venet. I think maybe I need a cup of tea today. Yeah, so Jianan, since Kagan fits the original distribution so well, have you compared it with the augmented data and other basic augmented approaches based on the original distribution? So reweighting or oversampling of the minority classes.
Yeah. So this is what we've done. So basically, the smooth algorithm is one of those oversampling methods. But of course, the biggest, smooth, as I said, is very popular, and it's not computationally expensive, meaning that you can actually generate data quite quickly. One big limitation of smooth is that first, it's difficult to generate authentic data, and second, and I think this is an even bigger challenge, is that smooth by itself cannot capture correlations between variables. So, because of course, we know that, especially in terms of clinical variables, some are correlated perhaps higher than others. And these kind of correlations are important and are clinically meaningful as well. So, when we are generating synthetic data, we have to make sure that we maintain also correlations between individual variables within the data set. And this is something that smooth cannot do due to its design. So I think these are the two major limitations. I'm sure there are many others, but these that come to my mind right now in terms of using, simpler methods such as oversampling.
Fantastic. Many thanks, Venet. And just to kind of finish, you put a call out there as well at the end of your presentation on those that are interested in collaborating, and we've got your contact details and sharing that as well too. And then one of the things, just lastly, you reflected on synthetic data kind of being one of the approaches that the NHS it kind of to overcome barriers to the access to NHS data. Is there an example, because we have a real mixed audience, is there an example that you can think of where synthetic data's being used in that applied sense, or are we not quite there yet? Just a reflection from you, Venet.
Yeah. So I think one thing that I'm seeing right now is that, there are quite a few, works out there. They say, okay, we can generate synthetic data. Here it is. But as I've shown here, is not as simple as that. I think, there are many other considerations, and perhaps even some that beyond what I presented here, that need to be, very careful taken into account before you know, we can use synthetic data for things like, you know, advancing research and things like that. So right now I'm involved in several initiatives with both, well, some of the local hospitals here, but also wider NHS, some of the NHS trusts, where we are looking at understanding, you know, can we apply some of these kind of architectures, these generative architectures, in order to allow the data to be shared widely? I think in answer to this, to your question, I think we are probably not there yet. It will take a bit more work to understand better aspects around, you know, evaluation is one, but also aspects around, you know, confidentiality, privacy, and of course, you know, commercial aspects as well, because, you know, we know that clinical data has a lot of commercial potential. So yeah, I mean, we are working on it, but we are still not quite there yet.
Lovely. Thanks, Venet. Joe.
Yeah, thanks. You touched on kind of security and privacy, and I guess that's another consideration with really highly accurate synthetic data. You know, if we imagined, you know, multimodal, the future, fast forward 5 years, we've got highly accurate synthetic multimodal data sets. There's obviously concern about being able to extract real patient information out of data sets. And I just wondered what your thoughts were on that when it comes to kind of patient cybersecurity, etc.
Yeah. So this is kind of, you know, the other side of the coin, really, because as I said, you know, we want to for this for the synthetic data to be as high fidelity as possible, so they reflect the characteristics of the real data. But at the same time, the higher we go in terms of fidelity scale, the more risks there are in terms of patient re-identification and risks to privacy. And finding, you know, kind of the sweet spot is challenging, I think. So right now, I'm working with a colleague of mine that we are looking at this problem from kind of information theory point of view. So we are trying to understand, you know, how much data, how much information actually leaks into synthetic data, and how much risk that is in terms of, you know, privacy and patient re-identification. So this is, I think, you know, this is probably one of the most significant challenges. I don't think it's going to have a kind of, you know, one answer fit all, because, you know, for some data, some of the data providers might be a bit more relaxed with, you know, issues around confidentiality and privacy, perhaps because of the data, you know, it might be anonymized or for whatever reason. But for some types of data, we may need to compromise fidelity. And, you know, then the question becomes, at what point is that data useful? So, you know, these are, you know, the kind of aspects that still need, I think, to be discussed. And, you know, we are really at the very, very beginning of kind of uncovering these issues. So I think that will also take some time.
Fantastic. Thanks, Venet. They're really interesting and thorny issues and great, well, yeah, methodological challenges. But so yeah, the call is there to reach out if you're interested in those areas and working with Venet and others. So thank you so much, Venet. I think that's us kind of drawing to a close. Our next meeting is on, oh, I thought I had my timeline and I don't.
I can say, Felicia.
Thanks, Emma.
So it's on the don't worry, it's on the 16th of April, so after the Easter holidays, school holidays, so it doesn't coincide with that. And we're actually having a slightly different meeting, so we're going to have a getting into AI career panels for clinical AI meetings. So we'll actually have a panel of people, experts working in clinical AI that will talk quite personally about their own career journeys, their challenges, how they got into clinical AI, and you'll be able to ask them lots of questions to help you get started or move forward in your clinical AI journey. So yeah, so I think I'm really excited about that. I think it'll be really interesting.
That's going to be a really interesting one. Thanks ever so much, Emma. Thank you to everyone for joining today, for your questions in the chat, and for introducing yourselves as well too. As always, these are fantastic hours out of the day, really fascinating. So I look forward to seeing you all in April, and hopefully at some of our fringe events too. Please do share far and wide. There's a number of them, and the AI UK runs over 2 days, but you can drop in and out of it. There's a really extensive program on there as well too, so pick out the bits that you're interested in. So thank you ever so much, and have a lovely afternoon. Thanks. Bye, everyone.
Everybody. Bye.
Bye.